All right, so for our third and final example, we now have elevated to the fact where there's two radicals in the equation. So for this, what you have to do is you have to isolate one radical. You have to get one radical by itself. So this square root of 6x plus 7 is already by itself. So we're going to have to square the problem ultimately twice, because the first time we're going to go ahead and just focus on getting rid of this radical. So I am going to take this to the second power, which means I have to take this whole side to the second power. And remember, you cannot distribute that exponent over addition. So over here, this is really beautiful. The square root of 6x plus 7 squared, those cancel out, and you're left with just 6x plus 7. But over here, think about what's really happening. What I really have is the square root of 2x plus 3 plus 2 times. So what do you think we're going to have to do? Yeah, we're going to FOIL this. So, ready? Pay close attention. We're going to take the square root of 2x plus 3 times the square root of 2x plus 3. Think for a second. When you multiply two radicals that are the same, side note, the square root of 5 times the square root of 5 is regular 5. The square root of x times the square root of x is regular x. So what do you think the square root of 2x plus 3 times the square root of 2x plus 3 is going to be? 2x plus 3. And then we're going to take this square root of 2x plus 3 and we're going to multiply it by 2. So I'm going to get 2 square roots of 2x plus 3. And then I'm going to take this 2 and I'm going to multiply it by the square root of 2x plus 3. And I'm going to get another 2 square root of 2x plus 3. And finally, I'm going to multiply 2 times 2 and get 4. So now I can go ahead and start kind of cleaning up my like terms. These are like terms, and then I also have this 3 and that 4 that are like terms. So I still have this 6x plus 7, and now I have a 2x plus 7 because I did my 3 and my 4. And then over here, I have 4 radical 2x plus 3. Okay, so now I can go ahead and start trying to isolate this radical. So you can see I've gone from an equation that has 2 radicals in it down to an equation that just has 1 radical in it. So I'm going to go ahead and subtract my 2x from each side. I'm also going to subtract my 7. So here I have 4x equals 4 radical 2x plus 3. And we're still trying to get this radical by itself. It still has this extra times 4. So go ahead and divide by 4. And now I have x equals radical 2x plus 3. So now that I've gotten this radical by itself, I can go ahead and get rid of that by squaring each side. And I lucked out because when I squared this side over here, it's just an x that has to become squared. So now I have x squared equals 2x plus 3 because when I squared my radical, that canceled out. So now I'm creating this quadratic equation. So I have x squared minus 2x minus 3 equals 0. So I'm going to factor this. Find those numbers that multiply to be negative 3, add up to be negative 2. So negative 3, positive 1. So this tells me that x equals 3 and that x equals negative 1. So now we're still having to check for extraneous solutions. So I have to take this 3 and I have to take this negative 1. I have to go back into this original problem here and I have to make sure that it's making sense. So if I want to go ahead and check 3. Okay, so I'm going to plug in 3. So 6 times 3, 18, plus 7 equals the square root on this side. 2 times 3 is 6, plus 3, and then we still have this plus 2 out here. So 18 plus 7 is 25, so the square root of 25. 6 plus 3 is 9, so the square root of 9, plus 2. Now remember, these are the square root of 25, so the only value I have is a 5. This is not a plus or minus because the square root already started printed on my paper. So this is going to be 5 equals 3 plus 2, 5 equals 5. This is good. 3 is a working answer. Now I'm going to go and I have to check 1, negative 1. So I'm plugging that back in here. So 6 times negative 1 is negative 6 plus 7 equals the square root of 2 times negative 1 is negative 2 plus 3. And I have that plus 2 from the original problem also. So now negative 6 plus 7 is 1. So I have the square root of 1 over here equals the square root of 1 plus 2. You can kind of see already this is not going to work. 1 does not equal 3. So negative 1 is going to be an extraneous solution. All right, let's try another one of those.